All right, here we are in 8.5 on annuities, methods of saving and investments. What you're going to learn this section is going to be determine the value of an annuity, determine the value of an annuity using a spreadsheet, determine regular annuity payments needed to achieve a financial goal, determine regular annuity payments using a spreadsheet, understand stocks and bonds as investments, read stock tables, and then understand accounts designed for retirement savings. So annuities, what are they? Well, annuity is a sequence of equal payments made at equal time periods. So an IRA is an example of an annuity you've probably heard of. Now, what is the value of annuity? Well, it's the sum of all the deposits that you make plus all the interest that's paid. And one way to do this is using compound interest formula. And the compound interest formula is A, which is going to be our future value, is equal to P, which is the principal, times 1 plus the rate as a decimal raised to the power T. Now, let's do an example with this. So say we deposit $2,000 into a savings plan at the end of each year for 3 years. The historical rate of return is equivalent to 10% per year compounded annually. Assuming the historical rate of return, find the value of the annuity after 3 years, and then find the earnings on this investment. All right, so first things first, we're going to have to do this year by year. So first one, let's do year one end. Okay, well, year one end, that's when we're going to deposit $2,000. Okay, so that's all we can do. There's no interest. It's just that's what we deposit at the end of the year. So then we go to year two end. Well, year two end, we're going to get interest on that first $2,000. So we're going to take that 2,000 times, and then we have 1 plus 0.1 for the decimal, and that's going to be raised to the power 1 because it's just 1 year. And then that's going to give us what? Well, that's going to be 1.1 times that, so that's going to be 2200. Okay. And so then what have we going to do after that? Well, remember at the end of the year, we're going to deposit another $2,000. So if we add $2,000 to that, at the end of year two, we're going to have $4,200. All right. So now year three end, well, what are we going to have? Well, now we have $4,200 times 1 plus 0.1. We did 1 year, and that's going to be equal to. Now, if we need to, we can go to a calculator and we can say, okay, well, now we're going to take, and we'll take the 4,200 times, and then it's going to be times the 1 plus 0.1. Well, 1 plus 0.1 is going to be 1.1. And so that's going to give us 4,620. And so that gives us here 4,620. And then what are we going to do the end of year three? Well, we're going to deposit another $2,000. So another $2,000 is added here. And so that's going to be 6,000, and then that's going to be $620. So that is going to be the value of the annuity after 3 years. So that's going to be our final value. Now it says find the earnings on this investment. Okay, well, earnings on the investment. How much have we total invested? Well, we've invested 2,000 here and 2,000 here and 2,000 here. So we've invested 6,000 out of that 6,620. So if we take 6,620 minus 6,000, that's going to be $620 basically in interest that we've earned off of this investment. Okay. And so that's how we would do a simple one of these kind of with the compound interest. Now, sometimes we don't do just plain old compound interest like that. Sometimes it's going to look something more like this. So if P is a deposit made at the end of each year for an annuity that pays an annual interest rate R in decimal form, again, all the rates have to be in decimal form, compounded once a year, the value A of the annuity after T years is given as this. So what we were doing was year by year by year. But what if we want to know T years in the future? Okay, so then we can use this formula. And when we do that, we can do a problem that looks something like this. Suppose that when you're 25, you deposit $3,000 into an IRA at the end of each year for 40 years. If you can count on a rate of return equivalent to 8% per year compounded annually, how much will you have from the IRA after 40 years? And find the earnings on the investment and round to the nearest whole dollar. All right, so again, we're going to use that equation. So I said the future value A was equal to how much we're going to deposit each time. Well, that's $3,000. So 3,000 times. And then we had the 1 plus our rate, which was 0.08. Again, we have to convert it to decimal form. And how many years? It's t is going to be 40 years, so that's going to be 40. And then that was minus 1 all over, and then it was just by 0.08. So now what we have to do is we have to plug that into our calculator. And so to test that out, let's clear that out. So we're going to take 3,000 times, now we'll have a 1 plus 0.08 raised to the 40. And then remember to arrow down if your calculator doesn't do that automatically. Then minus 1, and then we'll have in parentheses. So now we have this piece minus 1, all that's in parentheses, and we divide that by 0.08. And we get $777,169.56. And so if we go back over here, that gives us, again, $777,169.56. All right, now to the nearest dollar. Okay, so we have to think about this in two ways. How will the bank give it to us? Well, they're not going to round this number up. So, in normal terms, this number would round up and we would say, well, that's going to be $777,170. But the bank is not going to round up. And so because of that, most likely what we're going to get is, oops, 777,169, and the bank is going to keep that extra 56 cents. And so this is probably more likely what you're going to see in this case. All right. So now it says find the earnings on this investment. All right, so how much did we invest first? So this is what our bank account or our RIA or whatever it is going to show at the end of those 40 years. But how much did we actually put in? Well, we put in $3,000 at the end of each year for 40 years. So we're going to take 3,000 times 40. Well, that's going to be 12 with 4 zeros. And so that's going to be 120,000. All right, so if we subtract that off of there, we'll take 777,169 minus 120, and we get 961,756. So it looks like this is how much interest we have earned on that original deposit of 120,000 over that 40 years. So we made $657,169. Okay. And again, we have to think about this as a banking viewpoint. And so that's why this value is not going to be the number they're going to give you, because they're not going to give you, oh, well, we'll give you an extra, 44 cents. No, they're going to say, okay, nope, we're deleting that and we only give you the 169. Okay. All right. So let's stop there and we'll come back for more.